The photograph is one of the most recognizable images of the Pacific Air War. A Japanese fighter sits abandoned in the tall grass of a tropical island, its cockpit empty and its wings crowded with U.S. troops posing for a trophy shot. The tail code T2157 is clearly visible in the sunlight. To the casual observer, the identity of this machine can seem obvious. It is often described as a captured Mitsubishi A6M3 Model 32, a zero variant that Allied recognition material at times labeled HAMP. On paper, the label looks settled. However, later summaries of wartime technical intelligence paperwork tell a different story. They associate this wreck with airframe numbers reported as 3116 or possibly 3189. For decades, many later writers repeated the written record as fact, but the paper trail is not the same thing as an identified artifact, and it leaves room for error. In early August 1943, Allied forces overran Munda Airfield on New Georgia. The fighting had been intense, but the retreat of the Imperial Japanese Navy left behind a massive accumulation of aviation technology. The airfield was littered with broken aircraft, spare engines, and discarded support equipment. Among the debris sat the fighter marked T2157. It was not a crash site in the traditional sense. The aircraft had been parked, camouflaged, and then left behind when the logistics of the Japanese defense collapsed. This created a unique opportunity for technical intelligence teams. They had access to an enemy fighter that still preserved key structures, even if parts were already missing. But they were not the only ones with access. Munda was not a quiet museum. It was an active construction zone. U.S. Navy Seabees were bulldozing the Japanese revetments to expand the runway for Allied aircraft. Wrecks that impeded the heavy machinery could be pushed aside, piled up, or otherwise removed from the work area. The fighter known as T2157 survived this purge only because it sat slightly off the main perimeter. This incidental preservation allowed it to remain visible, but it did not protect it from the foot traffic of thousands of men moving through the staging area. The primary obstacle to identifying this specific airframe was not fire or impact damage. It was the predictable behavior of victorious troops. This brings us to the concept of souvenir entropy. When a high-value military asset is captured intact, its information integrity begins to degrade immediately. The rate of degradation is driven by the density of personnel in the area. At Munda, hundreds of soldiers and Marines passed the wreck daily. They did not see a forensic site. They saw a source of aluminum and keepsakes. Souvenir entropy acts faster than corrosion. A data plate fits in a pocket. A cockpit clock fits in a pack. These items vanish first. Within days of the airfield's capture, the cockpit instruments were pried out. Control sticks were sawed off. The small metal data plates, which carried the manufacturer's serial number and date of construction, were removed and pocketed. Those plates are often the quickest, clearest proof of identity, and that is exactly why they vanish first. Once they are gone, the easiest link between the physical object and a production record is severed, and the airframe can become an anonymous shell. The skin panels are often cut away for trench art, and the fabric control surfaces are sliced off. By the time the formal Technical Air Intelligence Unit arrived to catalog the graveyard, T2157 had already been stripped of its primary identifiers. The intelligence officers did their best to reconstruct the inventory. Later researchers often lean on Captured Enemy Aircraft Report 17, which lists Model 32. Airframes at Munda under serial 3116 or possibly 3189. But if the data plates were already gone, those figures could have come from fragmentary paperwork, stenciled parts in nearby wreckage, or simple transcription error. The report was filed, stamped, and archived. It became an influential reference point, even if it was not the same thing as physical proof. This discrepancy matters because the Model 32 is a rare machine. About 343 were built, and it represents a short-lived evolutionary branch of the Zero design family. Understanding which specific airframe served at Munda helps historians track unit movements, including the group commonly associated with the T2 prefix, and to think more clearly about attrition in this specific variant. The tail code T2157 is a field-applied tactical marking, and it can change with transfers or reorganizations. Without the removable data plate, tying that paint to a factory identity becomes a forensic puzzle. And in forensic engineering, guesses are failure modes. What happened next is where the story turns hazy. Some accounts placed the wreck in the grass for a time, slowly degrading under tropical weather and souvenir hunting. Other accounts describe it being towed to the shoreline soon after the capture of the field, and later moved again during the war. Either way, the central problem remained the same. The paper record said one thing, and the metal was not yet being read. To resolve the discrepancy, someone would have to go back to the surviving structure and look where soldiers rarely look. Not at the dashboard, but into the bones of the tail. About 13 U.S. gallons. That is the rough amount of internal fuel capacity the Model 32 gave up in the redesign, roughly 40 to 50 liters, depending on how the tanks are tabulated. This number, more than any tactical decision by an admiral, helped dictate the geography of the air war in the Solomons during 1943. It helps explain why the fighter marked T-2157 could end up abandoned in the mud of New Georgia rather than safe at a rear area base. The aircraft was not a victim of enemy fire. It was a casualty of an engineering trade-off that prioritized speed over endurance. The Mitsubishi A6M3 Model 32, known to the Allies as the HAMP, was a transitional variant. It was built in a brief, limited run before the design shifted again. It was created to solve a specific problem. The earlier Model 21 had long wings that provided immense lift but suffered from a slow roll rate at high speeds. In air combat, the ability to change direction instantly is often more valuable than raw climbing power. The engineers at Mitsubishi attempted to fix this by modifying the wing geometry. This brings us to the concept of clipped wing aerodynamics. The engineering team made a decision to delete the folding wingtips found on earlier carrier-capable versions. They squared off the ends, reducing span and changing the way the aircraft rolled at speed. By reducing span, they reduced the moment of inertia, allowing the aircraft to roll faster. It also reduced drag, nudging top speed higher when paired with the new 1130 horsepower Sakae engine. However, every aerodynamic decision carries a penalty. The shorter wing reduced total area and raised wing loading. And in the Model 32's case, the engine installation changes also contributed to reduced internal fuel capacity. The result was a faster, more agile fighter that could not stay in the air as long. The loss of roughly 13 U.S. gallons of internal fuel capacity sounds minor in isolation, but across the long legs of the South Pacific it could erase the margin that brought pilots home. A standard early zero could often make demanding round trips with a fighting reserve. The Model 32 was far more likely to arrive with little to spare, or to fall short when weather, navigation, or combat stretched the clock. This brings us to the range constraint. When an aircraft lacks the endurance to fly from a secure rear base to the combat zone, the commanders are forced to move the base closer to the enemy. Because of this range pressure, Japanese commanders increasingly relied on forward fields closer to the fight, including strips like Munda, where units associated with the T2 prefix operated. This decision placed delicate, high-performance machines directly in a harsh environment. Munda was not a developed air station. It was a strip of crushed coral cut through the jungle. There were no hangars, the humidity was constant. The salt air accelerated corrosion on vulnerable components and stressed airframes that demanded careful maintenance. The mechanics worked in the open, often under bombardment, with a supply line that was slowly being strangled by Allied naval power. The environment began to change the evidence before the aircraft was even captured. The humidity attacked the electrical systems. The mud fouled the landing gear mechanisms. A fighter plane is a complex system of hydraulic and mechanical linkages that requires hours of maintenance for every hour of flight. When the supply of spare parts failed, the aircraft became unserviceable. The pilots did not lose T-2157 in a dogfight. They simply parked it. This is a common failure mode in high-intensity warfare. We call it logistical attrition. The aircraft remains physically intact, but it ceases to be a weapon. It becomes a static object. When the order came to evacuate Munda in August 1943, the ground crews faced a binary choice. They could evacuate the personnel, or they could try to salvage broken equipment. They chose the personnel. The Model 32 fighters that could not fly were left where they sat. Some aircraft may have been damaged or stripped to reduce the chance of immediate enemy use, but many were simply abandoned amid the collapse of logistics and time. The jungle environment then took over the custody of the airframe. Vegetation grew around the landing gear, locking the wheels in place. The fabric on the control surfaces rotted away, exposing the metal ribs. While the Souvenir hunters of Chapter 1 stripped the cockpit, the climate attacked the structure. This creates a race between preservation and entropy. The aluminum skin protects the internal components for a time, but eventually, the corrosion works its way into the spar. By the time the world remembered this specific aircraft, the fuselage had largely dissolved into the earth. But one component, the vertical stabilizer, stood clear of the vegetation. It was this piece of structure that held the key to correcting the historical record. For nearly 30 years, a single wartime report stood in for proof, pointing to serial 3116 or perhaps 3189. The hesitation in that paperwork says as much as the numbers. The carcass was already too stripped to speak clearly. Over time, the document hardened into truth in books and articles, even though it was only a human observation made under campaign pressure. And observations can be wrong. In the post-war decades, recovery teams and private collectors did return to New Georgia in search of surviving relics. By then, the jungle had consumed what remained of the famous fighter. The aluminum skin had corroded into white powder, and steel fittings were rusted solid. However, the vertical stabilizer and the rudder could survive longer than the fuselage, protruding from the overgrowth. At some point in that post-war salvage chain, those tail components were separated from the debris field and preserved. It was during conservation work on the tail section that the discrepancy in the wartime paperwork was brought into the light. To settle the argument, you have to understand how aircraft identities are really recorded. In aviation manufacturing, the identity of an aircraft is marked in 3 distinct ways, each with a different level of permanence. The first is the external stencil. This is the paint on the tail, like T2157. This is a tactical marking. It can be changed by a painter in the field in an hour. It tells you who flew the plane, not which plane it is. The second is the data plate. This is a small metal placard riveted to the cockpit wall or the cowling. It lists the serial number clearly, but as we observed in Chapter 1, it is removable. It is the first thing to be stolen. The third level of identification is the structural stamp. This is the failsafe. During assembly at the Mitsubishi factory, the manufacturing number is hard-stamped directly into the metal of the primary load-bearing structures. These stamps are often located on the wing spars, the firewall, or the front spar of the vertical stabilizer. They are not meant to be seen. They are meant to track the component through the production line. Because they are driven into the alloy itself, they cannot be removed without destroying the part. They are immune to souvenir hunters and field painters. When the conservators cleaned the corrosion from the front spar of the recovered stabilizer, they found a clear set of digits stamped into the metal. The number was 3353. It was not 3116. It was not 3189. The physical evidence contradicted the wartime paperwork that had been repeated for years. This creates a conflict between 2 forms of historical data, which we classify as paper versus metal. In the hierarchy of evidence, the physical object is the primary source. A written report, even one stamped secret by a military intelligence unit, is a secondary source. It is an interpretation of reality created by a human observer who may be tired, hurried, or guessing. The author of the 1943 report likely looked at a pile of parts or a nearby wreck and wrote down the wrong number, or perhaps they found a maintenance log that belonged to a different aircraft. The stamp 3353 is not an interpretation. It is a manufacturing fact. It confirms that the aircraft in the famous photo, the machine that served with the 204th Kokutai at Munda, was the 3353rd Zero built by Mitsubishi. This correction ripples through the historical record. It means that the operational history assigned to serial 3116 does not belong to this wreck. It frees the artifact from a false identity. By establishing the true serial number, we also re-establish the rarity of the object. Since only 343 Model 32 units were built, every individual airframe matters to the production census. Identifying this wreck as 3353 closes a specific gap in the Mitsubishi ledger. The paper report was a dead end. The metal stamp was a key. The identity of the machine was now solved, but the paint covering that metal still held a confusing layer of information. The tail code T2157 was visible, but beneath it lay another code, pointing to a different origin entirely. In the discipline of aviation archaeology, the decision to recover an object is governed by the physical integrity of the material. By the time a recovery team returned to Munda in the 1970s, the calculus of the site had changed dramatically since the war. The famous fighter was no longer a coherent machine. It was a collection of dissimilar materials degrading at different rates. The central fuselage, which had housed the cockpit and fuel tanks, had suffered catastrophic structural failure. The aluminum alloy used by Mitsubishi was lightweight and strong, but without protective paint, it was highly susceptible to exfoliation corrosion. After 3 decades in the Solomon Islands' reign, the main body of the aircraft had effectively turned to oxide dust held together by the shape of the Earth. To attempt a full lift of the fuselage would have required a complex cradle system and chemical stabilization in the field. The structure simply would not support its own weight. However, the tail section presented a different set of conditions. Whether due to the angle of rest, the drainage of the terrain, or the specific batch of primer used on the rear assembly, the vertical stabilizer and rudder retained their structural rigidity. This created a hard boundary for the recovery operation. The team could not save the plane, but they could save the identity of the plane. The extraction process involved mechanically separating the empennage from the ruined fuselage. This is a surgical procedure. The goal is to disconnect the component at a factory production break if possible, or to cut through the compromised section of the fuselage skin to free the spar. Once the connection was severed, the tail section was removed from the context of the airfield. It transitioned from being a piece of wreckage in a jungle to being an artifact in a chain of custody. This is the beginning of provenance. The rest of the airframe was left in place. This was a calculated trade-off. The cockpit had already been picked clean, with high-density clues like the instrument panel long gone. The engine was too heavy and corroded to move without heavy machinery. The tail offered the highest return on investment. It carried the unit markings, the tactical code, and as we established, the hidden manufacturing stamp that proved the serial number. During the export process to Japan, the stabilizer was marked with a new identifier. The code J50 was painted onto the surface. This was not a military designation. It was a logistics tag used to track the crate as it moved from the Solomon Islands to its destination in a private collection. This mark serves as a method fingerprint for the recovery era. It distinguishes the artifact's modern history from its combat history. If you look at the stabilizer today, you see the layers of time stacked on top of each other. You see the original factory metal, the field-applied camouflage, the tactical number, and the recovery tag. The recovery of the tail was a partial success. It preserved the visual signature of T2157, but it finalized the loss of the fuselage. By removing the one identifiable component, the remainder of the wreck was condemned to anonymity. The pile of aluminum left at Munda eventually disappeared, likely scrapped or buried during later development of the area. The tail became the sole survivor. It was now a static display piece, safe in a climate-controlled environment. But as the restorers began to examine the paint more closely, they realized that the tactical code T2157 was not the only identity this aircraft had worn. Beneath the top layer of paint, there was evidence of a previous life at sea. Paint is not just decoration, it is a timeline. When forensic historians examine a recovered component like the tail of the Zero from Munda, they treat the layers of lacquer and primer like geological strata. Each layer represents a specific time, a specific location, and a specific ownership. While the structural stamp proved the manufacturing identity of the airframe as serial 3353, the paint reveals the operational life of the machine. The visible white code T2157 places the aircraft with the 204th Kokutai at Munda, but the paint laboratory tells a more complex story about how it arrived there. During the conservation process, analysts carefully abraded the surface paint to inspect the layers beneath. Underneath the T2 code, they reported the remnants of an earlier designation, characters that some researchers read as DI in the lower strata of the camouflage. In one interpretation of Imperial Japanese Navy tailcode systems, DI is associated with the carrier Hio's air group in part of 1942, before later code revisions. If that reading is correct, it suggests this airframe may have worn carrier markings earlier in its life, before being absorbed into land-based operations. This brings us to the concept of cannibalization. In a standard engineering context, cannibalization refers to taking parts from a broken machine to fix a working one. However, in a strategic supply chain, it refers to the reallocation of entire assets from one unit to feed the demands of another. By 1943, the Japanese logistics system in the Solomons was breaking down. The production factories in Japan could not build aircraft fast enough to replace the losses suffered by frontline units like the 204th. To keep the land bases operational, the Navy began to cannibalize its carrier air groups. Carriers like the Hio were high-value strategic assets, but without a functional air group, they were severely constrained. Conversely, land bases like Munda were bleeding aircraft daily due to attrition and range pressure. In that environment, aircraft and air crews could be reassigned between carrier and shore-based organizations, as the Navy tried to plug holes faster than industry could replace losses. Sometimes that meant aircraft operating from forward fields under new codes, even if their earlier markings still ghosted under fresh paint. The paint on the tail of Serial 3353 captures this transfer in physical form. When the aircraft landed at Munda, the ground crews did not have time to strip the airframe and repaint it from bare metal. They simply applied a fresh coat of green or gray over the existing markings and stenciled the new T2 code over the old DI code. It was a quick, functional change made in the field. Over the next 30 years, as the top layer of paint oxidized and faded in the sun, the original identity began to bleed through, creating a ghost image of the carrier code. This layering confirms that the 204th Kokutai was operating as a sink for material. They were fighting with secondhand equipment. The aircraft that the U.S. Marines posed on in that famous photo was a veteran of the carrier force, repurposed for a static defense, and finally abandoned when the fuel and parts ran out. The paint analysis bridges the gap between the factory stamp and the gravesite. It shows that the aircraft remained a functional weapon until the moment the logistical support collapsed. The story of T-2157 is not just about a single plane, it is a case study in resource management under failure conditions. The written records missed this nuance. They saw a number on a list. The object itself recorded the full chain of custody. With the identity resolved and the operational history decoded, the only remaining task is to define the legacy of the artifact. The fuselage is gone, but the tail section remains as a permanent evidentiary record of the Munda Airfield. We do not know the final disposition of the fuselage of the aircraft known as T-2157. After the tail section was surgically removed in the 1970s, the remainder of the machine was left to the mercy of the Munda environment. It is likely that the aluminum structure eventually collapsed under its own weight, or that the remnants were cleared away as the field changed. The cockpit, the engine, and the wings are lost to history. They exist now only as pixels in a photograph and as data points in an incorrect intelligence report. However, the survival of the tail section ensures that the identity of the machine did not vanish with the airframe. The vertical stabilizer and rudder are currently preserved in a private collection in Japan. They are no longer weathering in the tropical rain. They are stable. But the value of this object is not just in its physical condition. Its value lies in its history. That chain of custody is the point. In the world of forensic recovery and museums, provenance is the documented chain of custody that links an object from its origin to its current location. Without provenance, a piece of aluminum is just scrap metal. With provenance, it becomes a historical document. For the Zero from Munda, the chain of custody is unusually clear. From factory delivery to carrier Hio, to the 204th Kokutai on New Georgia, to abandonment in the grass, and finally to the team that cut the tail free, each handoff leaves a trace you can follow. That continuity lets the surviving tail serve as a reference standard. It validates the paint schemes, the manufacturing techniques, and the material composition of the Model 32 variant. The recovery of this single component justifies the effort of the investigation. The Model 32 was a rare aircraft. Only 343 units were ever manufactured. Most were destroyed in combat or lost at sea. Very few survive in any form today. By recovering and verifying the tail of Serial 3353, the archaeological community managed to save a piece of this limited production run. If the team had relied solely on the written records, they might have cataloged the find as serial 3116. That number would have led them down a false path, attributing the history of a different aircraft to this wreck. The physical verification corrected the timeline. This case study reinforces the central lesson of aviation archaeology. The paper record is often flawed. Intelligence reports written in the heat of a campaign are subject to the fog of war. They contain estimates, guesses, and clerical errors. The metal, however, does not lie. The stamped serial number on the spar is a permanent witness to the truth. The remaining paint works like a quiet map of the unit's movements. When the paper and the metal disagree, the discipline of the field requires us to trust the metal. The image of U.S. Marines posing on the wings of T-2157 will always be the public face of this aircraft. It captures a moment of victory and contrast. But the engineering reality is found in the preserved stabilizer. It tells the story of the roughly 13-gallon fuel shortfall that stranded the plane, the cannibalization that carried it from a carrier to the jungle, and the Souvenir entropy that stripped away its identity. The fuselage is gone, but the investigation is complete. The file on serial number 3353 is closed, not as a theory, but as a verified fact.